This video demonstrates Visplause, a visual approach for data quality assessment. As motivation, let us consider a real-world use case from the energy sector. As a basis for forecast models, the production of 95 photovoltaic power plants has been acquired together with dozens of meteorological measurements as hourly time series. However, as for most real-world datasets, the data is afflicted by many data quality problems. For example, some power plants show an unexpected production of 0 for several days or weeks. Meteorological measurements have missing values, as well as unplausible peaks. Automated plausibility checks are commonly used for detecting such data quality problems. But how can justified indications be distinguished from false positives? And how can users obtain an efficient overview that scales to dozens of checks on hundreds of data attributes? Visplause addresses these challenges to support multiple use cases. In this use case, we want to assess the fitness of given data for tasks like modeling or clustering. The assessment is based on results of a predefined set of plausibility checks. This is a common case for assessing regularly acquired data like sensor measurements. Visplause initially provides a compact and intentionally simple overview by aggregating all checks. 254 checks have indications for some part of the data, and 148 data attributes are affected by indications overall. In the indication frequency column, stacked bars show the overall percentage of data records with and without check indications. Small triangles show the percentage of affected data records for each problem class, for example, constraint violation, missing, and anomaly. We use scale-stacked bar charts to ensure the visibility for each order of magnitude while using a linear scaling for a fast interpretation. But which data attributes are affected by which indications? A hierarchical definition of table rows enables to define according drill downs instantly. Sorting the rows by their percentage of affected data records reveals that some power plants have many anomalous hours. Users may now define further drill downs. Clicking on the plus sign defines a local drill down by check classification for that data attribute. Its problems apparently comprise missing values, a few consecutive non-zero duplicates, and zero production during daytime. The hierarchical definition of rows is very flexible. For example, all nodes of one hierarchy level can simultaneously be expanded and collapsed. Likewise, the hierarchy levels can be reordered via drag and drop. This reveals missing as most frequent type of anomaly, followed by 0 at daytime. Visplause supports multiple types of columns. An additional column shows the distribution of the indications over time. Centered rectangles represent the proportion of indicated data records per month. For example, we see that 0 at daytime occurs particularly often after July 2010. Expanding this row shows that only a few power plants have indications in the entire period. Also, most plants have indications in January and February, but not all of them. Resizing columns affects the shown level of detail. Additionally, hover-triggered control elements like sliders allow to modify the shown range. Most power plants have 0 production on January 24th. Additional distortion enables to locally increase the degree of detail even further. In general, Visplause is intended as one important element in the process of data quality assessment. Our implementation is integrated as a part of a comprehensive visual analytics system, providing several visualization types as linked views. Selecting the indicated data records of January 24th for one power plant in Visplause allows an assessment with context in a time series view. Also, the values with indications are shown as text in a table. Inspecting the entire time series confirms the day as the beginning of a longer period. As another example, occurrences of non-zero production at nighttime can be inspected in the same manner. Looking at details for the two affected power plants shows that one of them has values only marginally above 0, maybe due to some light installation nearby. However, the second power plant seems to have a significant offset for a long period of time. Visplause supports to discretize quantitative plausibility checks. Multiple thresholds may, for example, be used to distinguish different levels of severity and may be shown as additional column. In this example, we see that the anomalies are classified as uncritical for one plant and as critical for the other. To conclude the first use case, we gained much information about data quality problems in a short time. Overall, the data quality seems sufficient for downstream tasks like modeling or clustering. However, steps like a selection of suitable data subsets seem necessary, and some errors require further investigation. In the second use case, we demonstrate how Visplause helps to generate hypotheses about possible causes of data quality problems. To focus the analysis on a specific group of checks, the user can define arbitrary tags for checks and use these tags for partitioning. This tag, for example, groups all checks concerning the production of power plants. A drill down by check class and data attribute now shows that missing values only occur for 5 of the 95 power plants. The temporal distribution shows that missing values occur throughout the whole year. But there might be other data attributes that explain these missing data. A linked rank by feature view within our system allows the user to address this question systematically. Assigning all meteorological measurements shows their value distributions and statistical measures. A useful metric for finding possible explanations is the relevance for the current selection, quantified by mutual information. After selecting the missing values in the production of plant 2, the data attributes can be ranked by their relevance for this selection. This suggests a relationship with the air humidity of weather station 1. The humidity can now be added as an additional distribution column in Visplause. Apparently, the missing values of plants 2, 3, and 6 occur particularly often at the same time as a high humidity. Selecting the missing values of the remaining power plant shows that humidity seems to play a role there as well, but from a different weather station. Concluding this second use case, we quickly identified a possible cause of a data quality problem. The resulting visualizations are a suitable basis for communicating these problems to data providers. The goal of the third use case is the selection of data subsets with a sufficient quality for downstream tasks, for example, a clustering of power plants. As this task only involves the power production, we restrict the set of shown checks accordingly. Visplause offers various filtering options for checks, for example, based on data attributes. As a next step, we decide to exclude those power plants that have critical indications and warnings according to the severity level column, and where more than 5% of the data records are affected by these indications. The remaining data attributes and their clean data records can now be selected by a single click. This data subset can now be used within our system or exported to other applications. For example, pressing Ctrl+C exports the selected data to the clipboard, allowing to paste the resulting data matrix into a spreadsheet software for further processing. The fourth use case illustrates the identification of new plausibility checks and the optimization of existing ones. We are exploring data attributes as overlaid curves per day. This reveals an unusual value at 8 p.m. for global radiation at weather station 1. Using Visplause, we can confirm instantly that this anomaly is not yet covered by existing checks. Based on this discovery, we decide to create a new check for this type of anomaly. Our system enables to define new checks based on scripting. We call the check Radiation After Sunset. The check can be implemented in different scripting languages, in this case Python. In this video, we copy and paste an intentionally simple script for demonstration purposes. This simple script tests all non-zero values after 7 p.m. against increasingly strict thresholds. In real-world settings, the script would have to consider different times of sunset across the year. The complexity of scripts is not limited in our system, but as a proof of concept, we use the simple script for now. The new check has appeared in Visplause. A drill down by the severity level enables to compare the effect of the various thresholds. Clicking on the indications shows that the default thresholds are apparently too strict due to too many false positives. For check optimization, a property window enables the user to modify the thresholds. The results in Visplause are updated immediately. A threshold of 20 for uncritical indications is still too low, so we set it to 50. These values seem to obtain reasonable results. As this anomaly could occur for other data attributes as well, we applied a check to the global radiation of all other weather stations. In fact, Visplause shows similar anomalies for multiple weather stations at multiple days. However, the anomaly co-occurs at multiple stations at the same time, for example, on the 1st of September. In the future, the identified checks can regularly be applied to newly acquired data.